Alright, in this video we're going to be talking about linear functions, and what a linear function is a function that has the form f of x equals ax plus b. Now if you watched some of the videos that I did previously about linear equations and the different forms of a linear equation, one of those forms we called the slope-intercept form, which was y equals mx plus b. So this is basically that same form, they just changed the letter m for the slope of the line to an a. Right, now the reason they do that when we write it in the linear function has this form is because for a lot of functions and the form of the function, especially for polynomial functions, for the coefficients for the numbers that are in front of the variables, they generally go in order like a, b, c, d. Right, so if you had like a higher order polynomial function, it would be like ax to the third plus bx squared plus cx plus d. So they just kind of use the letters in order. So that's why instead of mx plus b like we're used to seeing, here it's written as ax plus b. But it means the same thing, right? Like this says here, the graph of a linear function is a line that has slope equal to a and y-intercept equal to b. Right, so this is a linear function in that slope-intercept form. They're just using the letter a instead of the m for the slope. Right? But anytime you have a linear function, that number that's attached to the x, that's going to be the slope of your line, and then that constant number, the number that's added or subtracted that doesn't have the x attached, that's going to be your y-intercept of the graph. Right? So that's what a linear function looks like. Always has an x raised to the first power. That's how we can tell that it's a linear function. All right, so an example here, we have four functions, and we just want to say whether or not these functions are linear functions. Right? So to determine whether or not something is a linear function, we have to be able to write it in this form, f of x equals ax plus b. If we can, it's a linear function. If we can't get it into that form, then it's not a linear function. All right, so the first one, f of x equals 2 plus 3x. That is not exactly in the form ax plus b, but we can very easily put that in the form just by switching the position of these two terms here. Remember, when we have addition here, we're allowed to switch the order of addition. We call that the commutative property of addition. All right, like if I do 5 plus 7, that's the same thing as 7 plus 5, right? The order doesn't matter. Well, 2 plus 3x is the same as 3x plus 2, right? The order doesn't matter. So this one, yes, is a linear function, right? It's the a in this case would be 3 and the b would be 2. So if I were to graph this line, it would have a slope of 3 and a y-intercept of 2, right? F of x equals 3x plus 2. So that first one is a linear function. All right, the second one, g of x equals 3 times parentheses 1 minus 2x. Right, so that one definitely is not in this form ax plus b, but can we do some algebraic stuff to it to get it into that form? Well, this form of linear function doesn't have any parentheses, so if I want to test to see if this is a linear function, the first thing I have to do is remove those parentheses, and the way I do that is by distributing that 3, that number outside the parentheses, into the parentheses. All right, so that gives me, it's going to give me a g of x equals 3 minus 6x, right? So now it's kind of similar to this first one we had where we do have a constant, right? We have a 3, and we also have a term that has an x to the first power. So this is going to be a linear function, right? To get it exactly in this form here, right? G of x equals, I said over here, if I have addition, I'm allowed to switch the order of addition, and that's fine. Right? I can't just switch the order of subtraction though, right? If I do 5 minus 7, that's different than 7 minus 5, right? It gives you two different answers. But if I need to switch the order of something that involves subtraction, I can do that as long as I bring the negative with the 6x there. So if I write this as g of x equals negative 6x plus 3, I'm allowed to switch the order in that case. Think of this instead of 3 minus 6x, think of it as 3 plus negative 6x. All right, then I can switch the order of the 3 and the negative 6x, make it negative 6x plus 3, and then yes, this one is a linear function. It is in this form, f of x equals ax plus b. In this case, the slope of that line would be negative 6, and the y-intercept would be 3. All right, so the first two we had up here actually are linear functions, even though they weren't originally in that form. All right, the next one we have h of x equals x times 4 plus 3x. Right, so that one looks actually pretty similar to this one up here that we had, that g of x function. So maybe that one's also going to be linear. To test it out, let me distribute this x into the parentheses. But when I do that, you can see I'm going to get 4x plus 3x squared. Right, when I multiply x times x, that's going to give me an x squared. Right. Anytime I'm testing whether something is a linear function, anytime I end up with an x raised to a power other than 1, it's not a linear function. All right, so this one, the answer is no, it's not linear. There's nothing I can do to put this in the form ax plus b because I have an x squared there. Right? There's no way to get rid of that x squared. I can't just make it disappear. All right, so this one is actually going to be what we call a quadratic function because it has an x squared in it. All right, so those are the first three. Two of them were linear, the other one wasn't. The last one here, k of x equals 1 minus 5x over 4. Right, a lot of people look at that and say, well, it does have the x to the first power, but there's also a fraction here, and so that fraction means that it's not a linear function. This one actually is going to be linear. It's a little tricky, but I'll show you how this one works out. And I'm actually going to erase these other ones here so I have enough room to write this last one out. Right, so not everything that looks like this, that has a fraction, is going to be linear. If there was a 4x in the denominator instead of just a 4, if there was an x down there as well, then it would not be a linear function. Right? Anytime you have the variable in the denominator of a fraction, it's not going to be a linear function. Right? But if I have a fraction where the x is in the numerator, and then I just have a number in the denominator, I am going to be able to change that into the form ax plus b, and I'll show you how we do it. All right, so let me rewrite this here. K of x equals 1 minus 5x over 4. All right, so to do this, we have to, or the way to think about this is when you're adding or subtracting fractions, remember, as long as those two fractions have a common denominator, you can add or subtract them just by adding or subtracting the numerators. Well, I'm going to do that backwards here. All right, what I have is 1 minus 5x over 4. I can separate that into two different fractions. Right, I can make that 1/4 minus 5x over 4. Right? They have a common denominator, they're being subtracted. So if I were to combine these two fractions, I would subtract the 1 minus the 5x over that common denominator of 4, which is exactly what I started with. Right? So it's a little algebraic trick that does come up once in a while in algebra, in precalculus. It comes up once in a while in calculus as well. We have something like this that looks like a fraction, like, oh, that's really complicated, I don't know what to do with it. But if you separate the fractions, just keep each fraction with that same denominator, and then just separate the numerators, whether it's addition or subtraction, it works the same either way. Then you get two separate fractions, and a lot of times you're able to continue and do what you need to do with the problem. Right? Now, you're allowed to do that when your numerator has addition or subtraction. Remember, though, you cannot do that if the denominator has addition or subtraction. Like, so for instance, just as a side note, just so y'all don't make that mistake, right? If you have 4 over 1 minus 5x, that's not the same as 4 over 1 minus 4 over 5x. Right? Those two things are not the same. If I have addition or subtraction in the denominator, I cannot just split that up into two different fractions where I split apart that denominator. Right? It only works if I have a common or a denominator here, and then I have addition or subtraction in my numerator. I have to keep that denominator the same in both of the fractions I split it up to, which is not what we did here, right? Which is why this is not allowed, because what I split it up to does not have the same denominators as what I started with. All right, so it's a common mistake I wanted to point out to you. All right, so we have 1/4 minus 5x over 4, and then, just like with some of these other problems, I can rearrange this. I could write this as negative 5/4 x plus 1/4. And then, yes, we can see that this is a linear function, right? My a is negative 5/4. So the slope of this line would be negative 5/4. The b, the y-intercept, is 1/4. All right, so that was probably the trickiest one up there, but that one actually does turn out to be a linear function. All right, so again, the key thing is when something is a linear function, just have an x to the first power, not in the denominator of a fraction. You have a linear function, right? If you have x's in the denominator, or if you have x's raised to higher powers than 1, or if you have x raised to negative powers, or if you have x raised to fractional, rational powers, or decimal powers, it's not going to be linear, right? Only when you have an x raised to the first power that's not in the denominator, what you have is a linear function, and if you do a little bit of work with it, you can put it into this form of ax plus b.